This will be for the con assignment, two-way tables, Venn diagrams, and probability. So just some notes to start. The definition of mutually exclusive, it's when the events have no overlap. Okay, so mutually exclusive events have no overlap, and the probability of events A and B equals 0. Okay, there's no way the events occur together. So for overlapping probabilities, the formula for the probability of A or B, it equals the probability of A plus probability of B minus the probability of A and B. Okay, so when they overlap, you have to subtract the overlapping part. And if the events are mutually exclusive, the overlapping part is 0. So probability of A or B is just probability of A plus probability of B. Okay, so 200 people were surveyed about whether or not they like recreational reading and academic reading. The following two-way table displays data for the sample of people who responded to the survey. In this sample are the events liked recreational reading and disliked recreational reading, mutually exclusive. All right, so mutually exclusive, that means they have no overlap. It has to be one or the other. So that would be the case. You can't, it says liked recreational reading and disliked recreational reading. You can't have both. It's either one or the other. Okay, and you can see that from this chart. Here's one row for liked recreational and one row for disliked recreational. So they're two separate items. There's no overlap. So that means yes, they are mutually exclusive. Okay, and for this assignment, there are two questions per problem. So find the probability that a randomly selected person from this sample liked recreational reading or disliked recreational reading. Okay, well, that's easy because since it has to be either liked or disliked, it's going to be 100%. Okay, since it has to be one or the other, those two are the complements of each other. So in this box here, it has to be a decimal or a fraction or a number. It can't be a percentage. So 100%, if you just move the decimal over two places, that equals 1. Okay, so you just enter 1 in the box for 100%. Now, if you just want me to prove it to you, that would be 100%. For liked recreational reading, we have 176 out of 200. And for disliked recreational reading, we have 24 out of 200. So when you add those together, it's just going to be 200 over 200, which is 1. All right? So if the events are mutually exclusive, if the events are complements of each other, they'd have to add to 100% for the probability of one or the other. So I'll just put 1 in the box. That's 100%. So a restaurant noted what type of food its customers purchased last week. Here are the results. Okay, you can see the Venn diagram. The purple circle represents burgers purchased. The blue circle represents fries purchased. Okay, this part in the middle right here are the percentage that purchased both. And this 20% here is the percent that purchased neither. All right. So in this sample, are the events burger and fries mutually exclusive? Well, is there overlap? We can see the overlap right in here. Right in here is where the two events overlap. So mutually exclusive means no overlap. But since there is overlap, the answer is no. They cannot be mutually exclusive. Okay? So select no for that answer. And then find the probability that a person bought burger or fries, okay? So basically, you have to subtract the overlapping part. There's two ways to do the burger or fries probability, okay? Two ways to do it. So probability of burger or fries, okay? We know this whole diagram represents 100%, right? And we have 20% of the people that didn't purchase burger or fries. So you can just say 100% minus 20% equals 80%. Okay, we just subtracted the people that didn't buy either one. So that would be 80%, and converting to decimal, you move it over two places. That's going to be a 0.8. Or you can say 0.80, same thing. And now, if you didn't like that method, you can use the formula probability of burgers plus probability of fries minus the probability of both burgers and fries. Okay, so that's more difficult. But if you look at the probability of burgers, this circle right here, it's going to be 15 and 55 for probability of burgers. 15 plus 55, right? And then, if you look at the probability of fries, it's this circle right here. So it's going to be 55 and 10. Okay? But then finally, you have to subtract the probability of both where they overlap. So this is the overlap here. You have to subtract 55%. Okay? That's because you wind up adding it twice. So 55 minus 55 cancels. That's just 0. 15 plus 55 is 70, plus 10 is 80%. So it's still just 0.80. Okay, same answer, but the first method is much easier. So just enter 0.80 in the box. Right here. Probability of burger or fries is 0.80. A civics teacher asked her students to indicate whether they believed each of two headlines. One headline was false and the other was true, but the students didn't know this. The probability that a student selected at random believed the true headline was 90%, and the probability that a student believed the false headline was 82%. She found that 75% of the students believed both. In this sample, are the events believe the false and believe the true mutually exclusive? Okay, well, 75% believed both. That means there is an overlap. Okay, mutually exclusive means no overlap. So the answer is definitely a no. All right, so pick no. And then the follow-up, the probability that a selected person believed the true headline or believed the false headline. Okay, believe true or false. So we have to subtract the overlapping part, just like we did before. Probability of they believe the true or the false. Okay, so how many believe the true? 90%. And how many believe the false? 82%. But we have to subtract the overlap. 75% believe both, so subtract the 75%. Okay, so 82 minus 75 is going to be 7, plus 90, that's going to be a 97%. Okay, remember, you can't enter it like that. You have to move the decimal over two places. It's going to be a 0.97. So just put 0.97 in the box. 0.97 right in the box. Okay, and by the way, if you want to convert these percentages to decimal before you add it, you can certainly do that. All right, the principal of a high school needs to plan seating for commencement. The following two-way table displays data for the students who are involved in this year's commencement ceremony. For these students, are the events senior and not in choir mutually exclusive? Okay, if that were the case, you'd have to have no seniors that are not in the choir. You'd have to have no overlap. Okay, but you can clearly see here's the seniors, and here's the column for the not in the choir. So there's 436 seniors that are not in the choir. So are they mutually exclusive? No, definitely not. So just pick no. And then what is the probability that a person is a senior or not in the choir? Okay, so I think we should just do it the easy way here. Here's the seniors and not in the choir, right? There's 436 seniors that are not in the choir. So that is the overlapping part. We're going to have to subtract that. Okay, the totals, the column totals and the row totals meet right here. So this is the total that's going to be in the denominator. Okay, so the whole thing's going to be over 480. Okay, so probability of a senior, if you look at the row for the senior and you go to the total, the seniors, you got 459 seniors. And for not in the choir, here's that column right here. If you go down to the total, the not in choir total is 439. Okay, so we're finding the probability of one or the other, so we're adding. However, we have to subtract the part where they overlap. So it's minus 436. Okay, so 439 minus 436 is just 3. 459 plus 3 is going to be a 462, and that's divided by 480. So that's it. They don't make you reduce the fraction. So just enter 462/480 in the box. Okay? 462/480.